All right, good morning, everybody. So welcome to SIS 220, System Level Programming. I think most of you know who I am. So I'm Dr. Burton Ma. I normally teach SIS 124, which is where most of you probably know me from. If you haven't been to my office, I'm in Goodwin 754. For office hours, that's where I'll be. Office hours aren't set yet. I have to go through a week of school before I figure out what a good time is for office hours. So those will be updated on OnCue when I know. If you need to contact me and you can't do it during office hours or after class or before class, you can try emailing me. If you do email me, somewhere in your message you have to tell me what course you're in. So almost every email I get from a student, they don't tell me what course you're in, and I have no idea what course you're talking about. And it's super annoying because then I have to go look you up and figure out what course are you in, or which courses are you in if you're in two of them at the same time. That I happen to be teaching. So make sure you put SIS 220 somewhere in the message so I know what you're talking about. That is my email address right there. Contact. So teaching assistants, there are 3 for this course. Their contact information is currently on OnCue. They have 1 hour every week. Each TA has a virtual office hour on Teams. So those will start next week. So you can ask basically your office hours are there to ask the TAs for help, mostly on the assignments. When it comes time for the midterm, and I guess towards the exam, you might be asking questions about the course material in general. So their information is right on the homepage of OnCue for this course. And everything else for this course is also on OnCue, so I'm not sure why I'm telling you all this. Lectures are recorded. They get posted eventually somewhere. So they get posted on YouTube. There'll be a YouTube playlist for the course. If you look back, on my YouTube site, you will find playlists for previous years as well. So if I'm ever behind on posting lectures, you can always go back last term, the year before that, and find a lecture that's probably more or less appropriate for the material that was missed. The lectures do get uploaded. Sometimes it takes me a while to do so. Okay, textbooks. So there's no textbook that you have to purchase for this course. There's many online resources that you can get to learn the material for this course. I provide you with Jupyter notebooks. If you use these in SIS 124, they work similarly for SIS 220. Except for SIS 220, I actually give you the software to install everything. So I'll explain that in a moment. Dr. David Lamb, who is now recently retired, he wrote some course notes for this course that you have access to if you want to look at them. They're very academic in nature, so they're very terse. They don't have any examples, or they have very few examples and no exercises. But the information there is relevant if you want to look at that. The library has many excellent online books. These are just 2 of them. Those links actually work. So if you ever want a reference to the material that's talked about in the course, you can look in the library for all sorts of stuff. Also, you can look online for all sorts of stuff. There's nothing secret about the material in this course. It's all very well known. I'm just going to jump to OnCue because a lot of this information is there. That's not what I want. Sorry. Okay, so you're probably most interested in the grading scheme. There's a change to the grading scheme for this term. So let's take a look at what's going on. So there's 6 assignments in the course. The first one is, I would say, easier than the others. So the first assignment is there to make sure you've got your computers or whatever, your work environment set up to actually do some work in this course. So it's worth a little bit less than your other assignments. You can see the weight here of the assignment. So assignment 1's worth 5. Assignments 2, 3, 4, 5, 6 are each worth 9. The midterm is worth 20%. The exam is worth 30%. The midterm covers only the bash content of the course. So it only covers the first 5 weeks or so of the course. The exam covers the remainder of the course. So the course is basically split into 2 major topics, bash and C. Now notice here you can also have this option of 0% on your assignments. And so I'll explain that in just a second. Late assignment policy. Let me make this a little bigger so you can actually read it. Okay, so as in SIS 124, there is a universal 3-day accommodation policy for all students. No questions asked. Right? So every assignment has a due date, and then you get 3 extra days to hand in the assignment. No penalties, no questions asked. Now, some students with academic accommodations occasionally require extra time. You need to contact me if you need the extra time. You need to contact me ahead of time if you need the extra time, right? And then I can hopefully do something or tell you, sorry, for these reasons, we can't give you the extra time. But if you need the extra time, you can always ask for it if you're one of these students with accommodations. As soon as you submit something, technically the TAs can start to grade it. So you may want to wait. Well, that's not true. So in principle, the TAs could start to grade it as soon as you submit it, and that never happens. So basically, the TAs start to grade after the 3-day accommodation period has passed. You can submit as many times as you like, right? So you might finish the assignment early, submit it, and then realize you did something wrong. Just resubmit the assignment, everything's fine. Again, no questions asked, right? So missed assignments, I'll talk about that in just a second. So there is a midterm. The midterm is written, it's in class, so it's going to be in here. If you missed the midterm for an academically valid reason, you have to contact me, fill in one of these, what are they called? A request for academic accommodation, or whatever the heck it's called. And then we reschedule you, hopefully the next week, to rewrite, or to write a makeup midterm. Now, you might choose not to write the midterm, so I'll explain that. Sorry, no, that's not true. You have to write the midterm, right? If you don't write the midterm, you end up losing the marks from the midterm. And then finally, there's an exam. Again, same thing, right? So if you miss the exam for an academically valid reason, you go through the regular process and you write a deferred exam. All right, so why are the assignment grades possibly worth 0? So any test possibly overwrites an assignment. Right? So if your midterm grade is greater than any one of your than any of the assignment grades for 1, 2, or 3, then your midterm replaces that grade. Right? So suppose you get 100% on the midterm. Effectively, that means you get 100% on assignments 1, 2, and 3, and on the midterm. Right? So if you miss an assignment, you don't have to worry about it. You can always make it up again on the midterm. Right? If you miss one of the first 3 assignments, you can make it up again on the midterm. And the same holds true for the exam. So if you miss one of assignments 4, 5, or 6, or if you get a very bad grade for some reason, your exam grade will replace that assignment grade, assuming your exam grade is higher than that assignment grade. Right? So your test grades override your assignment grades if the test grades are higher than the assignments. Right? 1, 2, and 3, the assignments are in Bash, so that's why the midterm replaces those grades. Assignments 4, 5, and 6, those are all C, so that's why the exam replaces those grades. All right, so that's new. We're going to try that out this term and see what happens. I should warn you that it is never the case that a midterm grade is higher than an assignment grade or an exam grade is higher than an assignment grade. So really, this only helps if you miss an assignment. Or if you're one of these students who happens to test very well. Right? And so there are some of you that test very well. You might choose to go with a, what would that be? So 5, 9, and 9. So that's 23? 18, yes, 23. So you might choose to go with a 43% midterm and a 57% exam, for example. It's up to you if you want to do it. I'm perfectly fine to handle your grade that way. Any questions about that? Super. What else is going on? So there's grading, assignments. So the assignments, it's the usual rigmarole, right? So you're supposed to do your assignments individually. You submit them on OnQ. You may submit as many times as you like up to the close date of the assignment. Whoops, sorry. Is all this correct? Yep. Midterm, again, I just covered that. Exam, covered that. And so I guess you need to know what the heck this course is about. And so this is called system level programming. And so basically what we try to tell you about are the basics of a Unix-like operating system. So I'll show you that in just a second. We talk about these things called shells and this scripting. And then we talk about programming in the C language. In a nutshell, basically you're going to learn about an operating system called Linux and how to use it, how to use the basics of the operating system. You're going to learn about Bash. So the Linux, well, not Linux. So the Unixes have this thing called Bash. Well, sorry. Unixes have these things called shells. Bash is one of these shells. And this is the shell that we use to write programs in this course. And then I guess 6 or 7 weeks of the course is spent teaching you the ins and outs of the C programming language. All right, so part of this course is an introduction to an operating system most of you haven't used before, I think. And so what is an operating system? You've all used an operating system if you used a computer, right? So if you're in Windows, you've used Windows. If you're on a Mac, you use Mac OS, Right, if you're in Linux, that's great. You've used Linux before. This course is probably pretty straightforward for you if that's the case. So your operating system is the software that manages your computer hardware. And it provides an interface to the hardware for other software on your system. So down here at the bottom, that's the hardware that belongs to your computer. So keyboard, mouse, CPU, network, disk, etc. Right? The operating system is the software that talks to the hardware directly. Right? Any other program that you might use, so like Word or Visual Studio Code or something else like that, video game, that talks to the operating system if it needs access to the hardware. Right? Well, it talks to the operating system in most cases anyway. And then finally, there's the user, which is you. You typically interact with the application directly. So you normally don't, so the user almost never interacts with the hardware directly. The hardware, I mean so obviously you use the keyboard and your mouse, but you don't actually control the signals that are going from your keyboard to your mouse and interpreting them. Right? So the user typically interacts with an application, which then interacts with the operating system, which then interacts with the hardware. Right? All right, so most of you in your everyday work almost certainly use a graphical user interface. Right? So if you're in Windows, you use Windows, and if you're a Mac, you use Mac OS. There is an alternate form of interaction, and it used to be the only form of interaction, and that's what's called a command line interface. All right, and so most of this course involves using a command line interface to interact with Linux directly. So I'm going to show you a command line interface in just a minute. The operating system that we're using is Linux. I guess more properly it's called GNU Linux, but everybody calls it Linux. And so Linux is a free open source operating system. It basically dominates all of the internet infrastructure. So if most servers on the internet probably run Linux. Mainframes, so these are the big computers, also probably run Linux or some version of Unix. Supercomputers are almost all Linux now. And most embedded devices, so these are devices that have a computer inside of them, but you probably can't tell because there's no keyboard or mouse or something hooked up to them. And so where's the Wi-Fi router in here? Well, even the projectors are computers, so those would be considered embedded devices. And so this is the operating system that we'll be using in this course. Okay, so if we're going to be using Linux in this course, how do you get access to it? CastLab has a small number of computers that you can boot into Linux if you choose. The number of computers there is very small though now. It used to be that every student would have to work in CastLab, but that was a long time ago. Nowadays, most of you, I think, probably work on your own laptops or computers at home. However, if you want an actual Linux environment and you don't want to install it at home, you can always come to CastLab and try to grab one of the workstations there. You can also remotely log into one of these things, but I've never had much luck doing so. Okay, if you've got a Mac, you're golden. Everything's good. Mac OS is close enough for our purposes. It's not Linux. It's actually a variation of Unix called BSD, but it's close enough for our purposes. There are some differences. Whenever there's an important difference, I'll tell you about them. Normally, it's going to affect you on the assignments. So you still need to install some software if you're on a brand new Mac. The instructions are on OnQ, but please wait a few days because I have to make sure that they're up to date. A lot of the software that we use in this course is all open source and it changes all the time. And so when somebody makes a change to one of their software packages, it has a tendency to break other things. Mac is particularly bad because whenever Mac updates their operating system, all of the core software breaks. And so wait a few days before you start to, well, wait until I post an announcement on OnQ saying the instructions for Mac OS are correct. You probably want to do the same thing for Windows, although I'm pretty sure the instructions for Windows are correct. So for Windows, the easiest thing to do is to install this thing called the Windows Subsystem for Linux, and then install Ubuntu inside of Windows, or whatever version of Linux you want. And so that's the easiest way to get things working on Windows. There are other options for Windows users. If you want to know about them, just ask me about them. They're much more complicated though. And of course, if you really want to, you can install Linux on your own computer, which I assume some of you have, but that's not required. All right, So what the heck is a command line interface? So the rest of this lecture is just a quick introduction to the first part of the course. Okay, so this is a command line interface, right? All you get is this blinking cursor, and all that you can do in this thing is type into the console. On a modern command line interface, you can often cut and paste as well, but that wasn't always the case. Right? And so the way that you interact with this interface is you type in commands. The software that's running in my terminal is called a shell. The shell interprets the command, and it does something. So it reads what you typed in, tries to interpret it as a command, and then tries to execute that command. Okay, so for most of you, when you're working on your computer, you've got a graphical user interface. So for example, you might be looking for a file on your file system. Right, and you've got, in Windows, you would pull up Explorer, Windows Explorer. On Mac, you might pull up Spotlight, or you might pull up whatever Finder or whatever the heck it's called, right? And so this is the interface that you're used to working in, right? All right, so, which is very different than this, right? So here's my command line interface. So this is currently Ubuntu, which is one of the variations of Linux. And I'm somewhere, I don't know where, right? All I can see is this $sign. And so I'm somewhere on my file system in Ubuntu, right? When you're in Windows or Mac, it's easy, right? You just pop this thing open and say, hey, I'm in my documents folder, right? Where the heck am I in this command line interface? Well, the answer is I don't know, but I can ask, right? So I can type in a command, so pwd, right? So pwd is short for print working directory. So most of the commands are short. So they're 1 or 2 or 3 or a few characters long. So pwd will tell you what folder or directory you are currently in your shell. So I'm in this folder called slash, and then home, and then slash, and then Burton. Right? So this is called my home directory in Linux. Right? So whenever I open up Ubuntu, this is the directory that I end up in. Okay, so what happens if I didn't bring that, okay. I had a list of stuff that I wanted to go through, but I forgot to bring that list. All right, and so this is your interface. You can see that one of the problems you're going to have is that you need to know what commands are available to you, right? And that's a big part of learning how to use one of these command line interfaces, right? On my current setup, there's something like 4,500 commands. Do I know them all? No, I probably know like 20 of them or something like that, right? And so there's thousands of commands installed on my computer. You don't need to know all of them, right? You're only going to have to learn, I don't know, say 20 or 30 of them, something like that. I haven't actually counted the number that you need to learn, right? But it's not a huge number of commands. So this used to be the only interface that you would have when working on a computer, right? And this was actually advanced. It used to be much worse than this. And so I guess back sometime in the 1970s, I guess, this is sort of the interface that you would have to work in, right? No, you don't even know what time it is, right? If you want to know what time it is, you'd have to ask. So I would have to do something like date, right? And so now I can find out, oh, it's Monday, January 6th, right, at 11:40, right? There's no calendar, right? But there is a program or a command that prints a calendar. Right? And so the command cal, at least on my computer, outputs the current month, right, as a calendar. And you can, these commands, they have what are called options, right? And so cal minus A1, right? And so in Linux, most of your options start with a hyphen. If they don't start with a hyphen, they start with 2 hyphens. And so here's the command cal minus A, and then there's an argument to the option, which is the number 1. Hopefully I got that right. Right? So I happen to know that minus A for the cal command is the after command. And so this means, this asks cal to print out the current month plus 1 month after the current month. So we get January and February. Right? So the other problem with learning with this course is that not only do you have to learn the commands, right, there are also the options that are associated with the commands. Right? So not only do I need to know that cal exists, I need to know that cal has options. And it could be the case that your command has many options. Right? So for example, your compiler that you're going to be using in the C part of the course has literally thousands of options that you can feed to it. Does anybody know what all the options are? Probably not, right? And so there must be some mechanism in order to figure out what are the options that a command has. I'll show you how to do that later in the course. Right. Okay, so what else can you do? So let's go back to our File Explorer. Right? So if I'm in a directory somewhere and I would like to know what's in the directory, well, the File Explorer tells me what's in the directory. Right? So it shows me all the folders and all of the files that are in the directory. My command prompt does not, right? So my command line interface doesn't tell me what the heck is in home Burton, right? But I can ask, right? And so the way you ask for the listing of the files in your directory is with the ls command, right? And there you go. So you press that, and it spits out a listing of all the files that are in your directory. That's not quite true, but I'll explain that in just a second. And so on a modern terminal, so that means a terminal most of you will be using, it will often be color-coded, and the colors will mean something significant. There's no standard for the colors. So if you're on a different version of Ubuntu, or if you've got your theme set up so that it's a white theme instead of a dark theme, the colors will be completely different. I happen to know that blue things are folders or directories. White things are just ordinary files. Green files are files that have a particular permission set on them, and we'll talk about permissions later in the course. Right, so I've got a bunch of directories, I've got a bunch of files, right? And so I can list the contents of the directory using ls. Right? Now, if you forget the name of a command, often what people will do is guess. Now the problem is, if you try to guess, so if I think, well, I want to list the commands in the directory, why don't I try listing the commands, right? If the shell doesn't know what the list command is, it'll complain. Right? Now, how it complains is different depending on your particular operating system. Right? So Ubuntu is configured in a way such that, or my Ubuntu is configured in a way such that it will actually suggest, hey, maybe you want one of these commands from this list here. Here's how you install them. Right? On a Mac, you're not going to get that. On a Mac, it's just going to say list command not found or something like that. Right? So if you don't know the name of a command, there's no real easy way to figure out what command do I want to use from the command line interface directly, right? So in your case, you're probably going to jump onto Google or go and review the course slides or notebooks and look things up there, right? And that's a perfectly reasonable thing to do. Right? Okay, what if I type in SL instead of LS? Well, it turns out SL is a command on my computer, so it's called Steam. It's short for Steam Locomotive, and it draws a steam locomotive going across your screen. Right? And so this started as a joke. Some programmer said, hey, instead of LS, what if I accidentally type SL and I make something go across the screen? So somebody spent who knows how many hours programming this up, and you end up with a steam locomotive going across your screen. The terminal was never designed to do something like that. So the fact that that works is fairly impressive. Useless, but fairly impressive nonetheless. Right? Okay. What else do we want? Oh, okay. So if I can list the contents of a directory, can I actually see what's in a file? Because again, remember, the only interface that you have to your operating system is through this window, and the only thing this window can do is display text. Right? And so you can see here a lot of the files that I have in my directory, they end with a .txt. Right? And so that suggests that perhaps these files only contain plain text. That's not necessarily the case. You can call a file whatever you want. And so I can name something x.txt, and it might be something, it might not have any text in it whatsoever. Right? But hopefully some of these files contain some text. So I have animals.txt here. And so if I wanted to see what's in that file, well, I can do that. There's a command to do that. Right? So the command is called cat, and you tell it what file you would like to look at. Cat is short for concatenate. So it reads the contents of the file that you ask it for, right? And then concatenates that output to the terminal, right? And so if I do that, it spits out cat, zebra, dog, and armadillo. So it looks like animals.txt is just a very short list of animals, right? If I look at unsorted, that's just a list of letters, right? That happen to be in unsorted order, right? And if I look at sorted, That, again, happens to be a list of letters. In fact, it's the letters in unsorted, but now they're sorted, right, from A to Z. Right. If you want to look at more than one file at a time, you can do that too. So cat will do that as well. Right. So if I specify multiple files to cat, cat concatenates all of the files together and displays the output to standard output. Right. And so it prints out the contents of all of the files concatenated together. Right, which is why it's called cat, right? It's short for concatenate. Okay, so I've got this file of unsorted stuff. Right now, if this is your only interface to your files to your operating system, it probably makes sense that a lot of the data that you're going to interact with is stored in a file, right? And that file is probably in plain text, right? Because the only thing that this terminal can show you is plain text. So if you have a file that looks something like this, right, a natural question to ask is, well, if it's unsorted, is there some way to sort it, right? So if all of the data that you're operating with is text, right, sorting text is a common operation. It's probably a pretty good chance that there's some command that can sort this text. And in fact, there is. There's a command called sort. Right? So if you ask sort to sort that file, right, it sorts the lines of the file in alphabetic order, right, and prints the result to the terminal, right. And so there is the contents of unsorted now sorted, right. And that's how I got the file sorted.txt, right. I saved that output to the file sorted.txt. Right. How do you do that? Well, you can do it like this. So, oops, sorry, sort. I can use that little greater than sign there. So that's a redirection operator in Bash. So it says, take the standard output from sort and send it to a file instead. So I can send it to also unsorted. Like that. Now no output goes to the terminal. Instead, all of the output goes to the file. And so if I look at also unsorted, that was the output that sort would have produced originally. Okay, and so the Unix operating system is made up of a whole bunch of these small tools, most of which operate on text-based data. Right? Each one of these tools is specialized to do one task, and the philosophy in Unix is that it should do that one task and it should do it well. Right? And so all of the tools that are part of the part of a standard Unix operating system, they all perform a single task, right? And the task that it performs, you can often configure how it does that task by specifying options to the task. Right? And so the way that you go about doing work in a in a command line interface is you string together a bunch of these commands. Right? So I might sort the file. I now have a sorted file. I can do something with the sorted file. Right? But you can actually chain the commands together. So for example, I can cat animals.txt and unsorted.txt. So we know what that does, right? It prints the contents of animals and unsorted to the standard output, right? But instead of printing it, I can send it to the sort command. Right? And so the vertical bar in Unix is called a pipe. It's called a pipeline. It's called the pipe operator. So I can take the output of cat and now send that output to sort. Right? Sort will sort that output. And notice that you now have the sorted contents of animals and unsorted all together in one big list. Right? And so by chaining these small commands together, you can produce fairly complicated sequences of commands. Right? So you can produce a very complicated result by using a bunch of small commands all strung together. All right, so there's, okay, so once again, that's the contents of my directory. Right? That's where I am, right? If you're in Windows or Mac, right, hopefully you've got your computer set up and you've got your files organized in some systematic way. Right? So in my documents directory, I've got a bunch of folders that have dates on them, right? They're years and terms, right? Not surprisingly, these are the folders that contain my teaching course, the courses that I've taught, all arranged by their term. Right? So if I go into 2025 winter, right? I see 220 here, right? 124 will also appear shortly. And so there's this notion of being able to change folders, right? So in Unix, a folder is a directory. But I can change directories in Unix as well. I just need to know the right command, right? And so the command in Unix is cd. All right, so I don't have a 2025 directory set up yet, so let's go to last term's 2024 directory and see what's there. So if I do cd 2024 fall. Oh, I should show you f, right? The terminal is case sensitive. So the letter f, the letter lowercase f is different than the letter uppercase f. So if I try to switch that directory, I get an error, right? There is no such file or directory. So don't forget, everything is case sensitive. So if I type in cd 2024f, right, that the shell changes to the directory called 2024f. It doesn't print anything out, right? So it doesn't say, hey, I'm now in 2024f. Right? One of the philosophies of the Unix operating system is that if a command succeeds and has nothing useful to say, it doesn't say anything, right? Which is very different than what people in 121 or 124 will often tell you to do, right? Your program produces some output. So that's not the case in Unix, right? So if I want to switch a directory, if the directory exists and I can go into that directory, it does it and doesn't say anything. Right? I can check that I'm in that directory, though, again, by printing the current working directory. Right? So notice that I'm now in root. That first slash is called root. I'll explain that more about that in the next lecture or two. Right? So I'm now in root home Burton 2024f, and let's see what's there. Right? And so this turns out to be the 220 directory for 2024 fall, last term. Right? You can see I've got a couple of assignments here. Right? I've got some lectures here, I've got the notes, and some other stuff. So let's go see what's in notes. And we see here we've got some funny looking files. And so in that notes directory is where the Jupyter notebook files live. And so I'll show you that. I guess I'll show you that in just a second. Let's go to bash. There we go. So in that directory, you see a bunch of files that end with IPYNB. These are all the Jupyter notebook files that you're going to be using for the bash part of this course. Right, I'll explain, OnQ tells you how to get these, and I'll explain how to get these later on. All right, so that's how you switch directories. So cd is the command that switches directories. Right? pwd tells you where you currently are. So what if I want to go back to my home directory? So I could type in cd home. So that works. Right? So any directory that starts with the / is called an absolute path. Right? And so that is the full name of the directory called Burton on my computer. Right? I'm just going to go to 2024 again. So now we're in home Burton 2024f. Right? I can also switch to the home directory in other ways. Right? So one way to do it is I can just type cd. If you type cd with no arguments, it switches to your home directory. Right? So there we are again. Okay. I can also do it by typing in cd and then the tilde. So that's the squiggle. Right? On my computer, it's in the upper left-hand corner. On your computer, it might be on a different key. Right? But the tilde is the expands to your home directory name. So that also ends up switching to home Burton. Okay, so again, we're in 2024f, right? So what's happened here is I was in the Burton directory. I switched to the 2024f directory. Right? That directory is inside the Burton directory. Right? So in other words, the directory Burton is the parent directory of 2024f. Right? I can go up to the parent by typing in ... Right? And so ... is short for go up one directory. And again, I'm back in my home directory there. Right? So again, you can see that using these commands, there's a lot that you need to know about using these commands. Right? Often there's more than one way to do things. And learning to choose, so first of all, learning what are the different ways is important. right? Learning to choose the best way to do things is also important. The exact best way is often up to debate. All right, so what time do we have? 5 after 12. Okay, so there is the basics of using the command line interface. There's lots of silly commands available to you in Linux. So usually you have to install these separately, right? So for example, there's a program called cowsay that I've installed on my computer. I use it a lot for this course because it's silly, right? Cowsay uses a cow to print a message, right? And so I can ask this cow to say this message hello. And you can ask it to say whatever message you want, right? There's another silly little program called Fortune that you can install. Fortune just prints out a random fortune. So it's got this big list of, it's got a file that contains, or files, that contain a bunch of random fortunes or sayings or things like that. Some of them are jokes, right? And so every time you run Fortune, it just prints out a random one of these, right? And so on, and so on, and so on. One of these days is going to get me into trouble. Some of them are rude. I haven't encountered one yet in class, right? If you want the cow to print out a fortune, you can, right? So you ask the cow, run the fortune command, right? And send it to the cow, right? And now the cow will say the fortune, right? And so on and so on. So there's lots of silly things you can do in Linux as well. I have a program called CMatrix installed, right? It shows you the screen from the matrix, which hilariously is very old for you guys. But anyway, Control C to stop it. And there's a bunch of other silly things you can do as well. Okay, so that's the very quick introduction to using a command line interface. Now, if you haven't been taking notes, don't worry about it. The Jupyter Notebooks actually has a notebook that takes you through the command line interface. So the notebooks for the course, give me a day or two to make sure the instructions are correct. You can install all this software on your computer. What ends up happening is you end up getting a bash environment and a C environment that runs in your browser, which is kind of neat. So all of the notebooks are written with lots of interactive code cells in them, right? And so on OnCue, in the lecture section, there is a link right here. There is a link to the online version of these notebooks, right? So if you're going to use this link, make sure it opens up in another tab. If you try to open it up in OnCue, it won't work. It just hangs, and then you wonder what the heck's going on. And so there's an online version of these notebooks if you don't want to install the software needed to run these. I don't recommend using the online version of the notebooks if you can install the software. Right. Okay, so in the notebooks, there's an introduction to the command line notebook, which is right here, right? And that notebook covers some commands that I didn't talk about today. It's not important. We're going to cover these commands later on in the course, right? And it covers some of the commands that I showed you today as well, right? You can run them directly in the browser, right? So the echo command prints a string, right? So that prints out hello world there. ls lists the contents of a directory, so that's going to spit out the contents of whatever directory the notebook is running in, right? And so you get that there, right? And so you can fiddle with these commands here. They're all editable, right? It works the same way as in 124. So you can edit the commands to your heart's content, right? So I can cat animals.txt. If I want to, I can also do fruits.txt at the same time. And hopefully I fixed this because I know this is buggy. Yeah, it works, right? And so you have this interactive version of bash that you can use as well, right? There's a notebook for every lecture in the course, and they're all here as of now. I think this says it's currently incomplete. That's probably not true anymore. This is probably more or less complete, at least for this term. Right, so all of the notebooks are there. If you want to, you can go through all the notebooks and you will know everything you need to know for the course, and probably more, right? And so again, give me a couple of days to check to make sure the installation instructions are all correct, and then go ahead and install the software, and you will have all of the course notes for the course. Okay, any questions about how the course works or the course in general? Super. I guess we'll start tomorrow with the actual course material. So we're just going to go back and it's going to be a leisurely lecture. We're going to talk very briefly about the history of Linux.